Thank you for the introduction. All right, so let's talk about the motivation for our work. So let's say we have a programming student who knows Java, but now they're starting a new course in OCaml, and they see this line in some starter code, and they don't really understand what's going on. So there's lots of different pieces of syntax that this programmer needs to understand what's happening in the code. So for instance, on the outermost form, we have a let binding, we have a function application, we have a tuple pattern, we have a wildcard pattern, just to name a few of the pieces that this programmer needs to understand. So what is this programmer supposed to do if they don't understand this syntax? So for this talk, I'm going to start off with some background about this problem, existing kind of strategies for how people might combat this, and then I'll discuss an early design we made for a system to try to help make this problem a little bit easier to solve, make it easier for people to find good programming language documentation. And then we'll discuss a formative study that we ran to evaluate this design and to kind of explore this design space. And then and then I'll show a demo of our current implementation that we have and talk about some future directions for this work. So I'm going to talk about two existing approaches. One is existing documentation that you can find online for programming languages, and one is going to an expert and asking them for help, and talk about how these approaches work as far as how contextualized this information is and how available this information is. So one existing approach would be to search online, try to find the answer. So for instance, the programmer might type something like, what does let with this tuple binding mean in OCaml? And we can see that while this information is always available, like as long as you have an internet connection, we can see that there's a problem with how contextual this information is. So you get sort of relevant search. I mean, you get like a reasonable result is talking about let bindings in OCaml. But if the programmer is specifically trying to understand how this let binding interacts with this specific pattern, this information isn't necessarily going to help because this is too general. It's not specific to the context the programmer is trying to understand. There's also more formal kind of documentation you can find. For instance, this is a page from the OCaml manual. But we can see that this has the same problem. Like this is technical information about what a let binding means in OCaml, but it's general to a pattern. There's some examples, but these examples may not be exactly what the programmer is really looking for, and this can be difficult for the programmer to find. So we see that on the scale of how available it is available, like I said, as long as you have an internet connection or own the book. It is available on demand, but the problem is that this information is not contextualized. It's hard to get exactly what information you're trying to find if it's not just kind of these general forms. So what about asking an expert? So this, in a teaching sort of context, this could be someone on the teaching staff going and asking them. In more of a workplace setting, this could be asking a lab mate who maybe knows, or asking a coworker who maybe knows the language better than you do. This is great in that you can have this kind of conversation, this interaction. You can show them the code, and they can answer questions specifically about that code. And you can kind of probe and ask for more specific questions about how these different pieces interact within the code, and get this back and forth dialogue. So this is great. You can understand it, and it's perfect, and it's wonderful. But the biggest problem with this is that the expert's not always available. You're not always going to have someone sitting right next to you as you're trying to understand this language. And so we see that that's where this existing approach kind of falls short. So I'm going to present today our system called ExplainThis. And this is trying to hit basically the best of both worlds, where we have really contextualized documentation that a user can kind of probe and ask for more detailed information about for things that they're trying to understand and is really specific to the code that they're actually looking at, while also being on demand and always available. So to speak about some kind of existing contextualized documentation tools and some design principles that we're drawing from, there are some of these design principles are being placed within or next to what is being documented. There is being contextualized to exactly what is being documented. There is being always available and showing multiple different representations or levels of information. So for example, we have Scholar5. This is an example of a tool that automatically generates context-sensitive information for technical terms and symbols that you would find in a scientific paper. And this follows the design principles of having documentation that's directed in the paper next to the terms that are being defined. And this information is contextualized to how it is being used actually in the paper. We have another example of contextualized documentation tools. This is Noda. It's a very similar tool, but specific to programming language literature and being interactive, an interactive way to consume this information. And this follows the same kind of principles and also strives to be always available, so always have the information for all the terms. We also have tutor-ons, which is a system for creating automatic and queryable explanations for code that you could find in like an online tutorial. And as far as its design principles, it also follows the principle of including these like multiple levels of information that you can, multiple levels of detail of information for this documentation. So ExplainThis is designed to align with all of these principles of being inside the editor that you're working with, next to the code that you're working with, being really contextualized, always available, and being able to show multiple levels of details of information and representations. So let's talk about our early design. Our early design was also influenced by a survey of existing kind of programming language literature or programming language documentation, and that's how we kind of base a lot of our structure that I'll show you. You can read more about that in our paper. So let's bring this back in the context of we've got this student who's learning this language in a classroom, and now they've been given some starter code to work on their homework assignment. So, like I said, one of our goals is that ExplainThis can always provide documentation on demand. And so how we accomplish this is we implemented ExplainThis in Hazel. So Hazel is a live functional programming environment. It's used as structure editor, and it uses holes. And what the use of these holes allows is that every program state is well-defined. So empty holes stand in places for missing parts of a program. So in the example on the screen, on the right of the plus operator, we are missing an operand. So a hole is inserted to make this plus expression well-formed. And then we also wrap parts of a program that have semantic errors and non-empty holes. So for instance, a Boolean is not of the appropriate type for integer addition, so that is wrapped in a non-empty hole. And the key thing that this provides with Hazel is that our tool ExplainThis can always provide documentation because it's always working on a well-formed program. There's always a valid syntax tree that we can work off of and provide information for. So let's talk about, there are three main parts to ExplainThis. So one of the parts that we use is we provide the syntactic form of the term that's at the cursor. So for instance, in this example, the programmer has their cursor on the case expression as shown by highlighting it in green, and we show the syntactic form. So this is a general case expression, and we can see that we use meta variables to represent, for instance, the scrutiny, the clauses, the patterns. We also provide an explanation of this form, and we tailor this explanation to be relative to the code that's actually in the editor, and we use color highlighting to associate between the parts of the explanation that are related to the parts in the code. So as we discussed, one of the design principles is allowing different kind of levels of information and representation that we can show to the programmers. So we provide what we call the syntactic form specificity slider. It's this bar on the end where basically the programmer can shift around You can think of it as kind of expanding or contracting parts of the syntax tree to get more detailed information. So for instance, in this example, the case expression that the program was specifically looking at was a case where we have an empty list pattern and a non-empty list pattern. So the programmer could indicate that they want this more specific information, and we can see that the explanation is updated to include information about things such as like the head pattern and the tail pattern and things specific to lists in these patterns. Whereas if they just wanted to understand generally like what a case is, they could shift to just kind of getting rid of all that extra information and just focusing on what a general case expression is. So we have one other main part to explain this, and this is showing code examples. And so these code examples can also be tailored to this level of specificity that the programmer is indicating. So for instance, if they had shifted to kind of wanting more specific information, we can see that these code examples are specific to patterns with for an empty list and a non-empty list. Okay, so now we're going to move on to talking about the formative study that we ran to evaluate this early design. So our main goals were we wanted to investigate this idea of adaptive levels of specificity. So how this kind of interactive slider works around what people think about how the documentation should adapt based on what the programmer is indicating they're trying to understand. We also wanted to explore some of the properties of explanations and examples that experts believe are helpful. So for this formative study, we focused on experts. We wanted to try to see, basically, we want to kind of simulate what maybe an expert would try to provide you with this really adaptive documentation. So for this initial study, we ran it with experts to try to figure out what experts would think would be helpful to provide to a novice trying to understand a language. It's left to future work to actually evaluate how well these things actually translate to a novice trying to understand and what's actually helpful to the novice. We also wanted to get some feedback just on our early design iteration. So we ran the study with 10 participants, and like I said, we used participants who are knowledgeable about functional programming concepts since we were working within Hazel. So there are people who basically were qualified and knew enough that you could go to them and ask them for help to try to explain these concepts. And we presented them with a small code snippet and a piece of the syntactic form that was at some set indication of how specific the information was supposed to be. And then we provided them with a set of explanations and examples and asked them to rank these and provide feedback on what they thought about these different explanations and examples in relation to this piece of code and where the syntactic form was on as far as level of specificity. So for some of the results that we found that some of the participants preferred a more fixed level of specificity for explanations. So for instance, if we showed them this small code snippet, which is a function application to a tuple argument, if we showed them an explanation such as this, which says apply function foo to argument 1, true, the argument is a tuple with first element 1 and second element true, so we can see that this is an explanation that kind of delves into some of the subparts of the syntactic structure. You can see that on the left side, we have a syntactic form that's just the most general version of a function application. And on the right side, we have a syntactic form that's specifically for a function application to an argument that's of the tuple form. And we can see that participants ranked this explanation highly for both. So they liked the extra detail of information regardless of where this level of specificity slider was, so that it was closer to the actual code snippet. Contrary to that, we've actually found that some of our participants preferred a more adaptive level of specificity for examples. So if we start with the same code snippet of a function application to a tuple, we can see that if we showed them an example such as this, which is just a very simple function application to an integer literal, when participants ranked this example higher for if if the theoretical student had asked for the specificity level of just a general function application to a general argument, it was ranked higher, as opposed to they felt it was less relevant and ranked this example lower if it was for a function, if the theoretical user had indicated that they wanted to understand a function application to a tuple argument, because this example was less relevant if the programmer indicated that that was kind of the piece of information that they were trying to understand. We also found that some of our participants really valued having really precise and uniform use of terminology for the explanations. So in this case, we have a similar example, but this is for a queried function application. And participants ranked higher an explanation such as apply function foo to argument 1 and then apply the resulting function to argument 2, which is giving a more technical and precise explanation of how function querying works, as opposed to an example an explanation such as apply function foo to arguments 1 and 2. So the bottom explanation is technically incorrect. There is exactly one argument to any function in Hazel. There are no multi-argument functions. You can get the same basic principle using function querying and using tuple arguments, but participants felt that, kind of trying to look over this level of detail was actually not going to be beneficial, and it was eliding too many details that they felt were important. As far as examples, generally participants preferred really small and focused examples. So if we showed them a code snippet such as this, which is a let binding for a tuple, a small example such as this, which is again just a let binding with a tuple example, it's about as simple as you could get it. This was ranked higher than an example such as the one that you can see on the bottom, which includes extra forms and extra more kind of considered complex forms, such as a case expression. This might be trying to hint at maybe more realistic examples, but participants felt that they'd really rather have just really small, focused examples, and those would be more useful to a programmer than adding kind of these extra forms that aren't really the focus of what the programmer is trying to understand. So as far as the UI went, we found that the participants found the specificity slider actually really unintuitive. So we had comments such as, this is not the way my brain understands code, this is not the way my brain works, and this is for experts. So these are for people who can explain these things to someone. So this is a really strong indication that this particular interface is maybe not the best choice for how we can kind of ask programmers to probe into what they're trying to really understand about these subforms and how they interact with other syntactic forms. So just to kind of summarize some of our main results from this formative study, I found kind of, in general, it's better to have perhaps fixed levels of specificity for explanations, give a little bit more detail, but really make the examples adaptive so that you're not showing examples that don't contain the particular pieces of information that the programmer is really asking about. And that we should use really precise and uniform terminology, use really small focused examples, and that we needed to iterate on the specificity slider design to try to come up with a better way for programmers to interact with this interface. So now I'm going to show you a demo. So this is still a work in progress. We're still iterating on these designs, but we'll show where we're at right now. So this is in the context of a larger Hazel UI overhaul, but we're going to particularly, so the overall interface looks a little different, especially with colors and things, but we're going to really focus on the specificity, the explain this portion. So we can see that the main structure was kept the same. So the biggest UI difference from what we had before is that instead of having the slider, we changed this to a drop-down. So this allows people who are trying to adjust the level of specificity to get a high-level view so that they understand kind of where they're going to be shifting and what level of detail of information without being, as opposed to the slider where it wasn't necessarily clear what you were going to see as you moved this around. So you can see that for this, this is a more specific sort of syntactic form where we're really talking about let bindings with tuple patterns, and we can see that the explanation goes into some of the details about like first elements and second elements, and the examples demonstrate this information. But we can shift this into a more general explanation of, just high level, like what is a let expression? And we've got definitions and patterns. We can see a similar sort of specificity change that we can make for instance, functions. We can have a more specific, if the programmer is trying to understand how a function works, if it's got this like 3 tuple, and we can get this more specific explanation that goes into the details and see examples that are tailored to exactly the form that's in the code. So you can see that we kept the color highlighting, but we also added it to syntactic forms so that the programmer is really able to associate this piece of the code, like this variable is associated with this part, like this meta variable in the syntactic form, and that's related to this kind of definition in the explanation. In case the color highlighting is too much, as you can see, like I can, oops. Like I said, it's a work in progress, so there's still some bugs. But you can see that maybe the color highlighting would be a bit too much if you're just trying to click around and edit, so we do allow them to turn off the highlighting. We also, as we're planning to deploy this into a classroom, and as we said, we wanted to get feedback from actual novices trying to learn the language, what they felt like were helpful explanations and examples. We added just a really lightweight mechanism for programmers who are using this to be able to give some feedback about what they found helpful or not helpful about these explanations and examples. So what are some future directions for this work? So like I said, we are planning to deploy this to an actual classroom. So these will be primarily the students come from a background of understanding like an imperative language, and then they're switching to Hazel, which will be, for many of them, their first real experience with a functional language. I want to deploy this, see what they think about the design, how helpful they actually find it, what do they think about the different explanations and examples that we're showing them. We can also think about making this documentation even more adaptive. So you can imagine having a better model of user knowledge. So for instance, perhaps the explanations, you can imagine if you're actually talking to someone and you're trying to explain something to them and they're coming from like C++, maybe you'd explain something differently than if you know they know Haskell. And being able to make use of this user knowledge, maybe we could create even more adaptive documentation that would be really helpful to people. You can also imagine using more information. So right now we're just using the syntactic structure of the code, but we can think of using more information about types or perhaps execution. Maybe you could kind of capture some of the execution so that the examples more closely resemble how the code is actually being executed, maybe with some values. You can also imagine making this more queryable. So like I said, kind of the benefit of the expert is you can have this kind of dialogue and ask them to probe into more specific parts, and making this an even more interactive and queryable sort of interface we think could be a great way to make this even more useful to novices. You can also imagine documenting things other than syntax. So for example, the type system, perhaps trying to explain better how certain typing is working, maybe if you're seeing a mismatch. And while we implemented this in Hazel to leverage the guarantees about always having a well-formed program, we can imagine implementing this for other languages. So just to reiterate kind of the key things that ExplainThis really provides as far as programming language documentation is it's always available on demand. It's really contextualized to the programmer's code, and it is able to be adaptive to different levels of information that the programmer is trying to understand. And the demo code is available at that URL. Feel free to play with it and let us know what you think about it. Now, I thank you for your attention, and now I'll open it up to questions.
Do people have questions? questions? Yes. Well, I'll have to make them up. Okay. I guess you can use the desk microphone and probably, no. I'm going to say repeat the question to your audience online, your fans online. But
thank you for the very interesting talk. I think something like this is one thing that is very missing from modern IDEs, and I'm very happy to see that someone is working on this. I wanted to ask about implementing ExplainThis for other languages. So right now we are actually seeing a sort of advent for language agnostic frameworks for IDEs. We have something like, I don't know, LSPs, and in particular, recently there's also, there is the tree-seater framework, which is a language agnostic framework for parsers. And do you think that there is some hope for basing something like ExplainThis on the ASTs which are generated by tree-seater?
Yeah, so as far as, so right now the process is very manual as far as actually generating explanations. We found with like our survey of existing programming language documentation, a lot of the examples and the explanations are really, they seem very hand-tailored and handcrafted. So I think it's an interesting question how we could make this, you know, more automatic so that it could be more easily implemented across languages, or as you add new structures, or it would allow you to, you know, delve into like different parts a little more. Right now we have kind of a set level of detail that we'll go into. I think that's a really interesting open question. I don't know how to solve that while also preserving, you know, having really meaningful explanations and examples that really fit. But yeah, I think that's a really, really interesting question that we've been thinking about. But I'm not really sure how to make this while still preserving, you know, having these qualities of explanations and examples that people seem to think are important.
Yeah, I thought that would be a problem.
Yeah.
Okay, we have another question here. If the next speaker could sort of start getting ready.
Hey, great talk. I'm curious how much you explored the representation of the sort of references back to the main application. I saw in user testing you found it was annoying enough that you needed to be able to turn it off. The colors. And so just as anecdata, we recently did a study of professional writers, and they find like the Google Docs style change sort of coloring, which is a similar sort of aesthetic, very distracting. And so there seems to be an opportunity to explore that more and improve that interface. When we get thoughts about how to do that.
Yeah. So we didn't actually turning the color highlighting on and off wasn't a result of the study so much as our like searching related literature that said, you know, you kind of want to minimize distractions, and we figured the coloring could be distracting, especially if you're not focusing on the documentation. Clicking around seeing the colors change would be a bit much. I forgot the second part of your question. Sorry.
I'm just wondering if you had thoughts about how to make it more comfortable to leave on, basically, or what you do.
Yeah, I think that's an interesting question. Yeah, because definitely we just have the on-off, and I think there's some space. Perhaps, like one idea is being able to leverage, or that I'm thinking of is like being able to leverage what a user knows. Like if you know they understand let bindings, like maybe you don't want to turn on the color for forms that are really familiar and they understand, but maybe you want to like pop this up if they're seeing something that you've never seen them interact with. Is one idea, but I think that's, yeah, an interesting open question how you don't have to manually turn it on and off, but being able to more like intelligently kind of pop these up or not.
We may have time for one more question while the speakers transition. So if the second speaker, yes, okay. Yeah, I think it's interesting work.
Stop sharing your screen.
Well, let's thank